Section 3.1 is on graphing linear equations. A linear equation is basically the equation of a line, and it's how we describe where the line is and what it looks like on the coordinate plane. And the equation of a line can be written in several different forms. The first one we're going to take a look at is called standard form of the equation of a line, and that is ax plus by equals c, where a, b, and c are integers, that is, they're not fractions or decimals, and they have a greatest common factor of 1. In other words, a, b, and c cannot all be divided by the same number. A has to be positive, and both a and b cannot be 0. To determine if an equation is linear, you can have no variables raised to a power, you can have no variables in the denominator, and you can have no variables multiplied together. So let's take a look at a couple examples here. Determine whether each equation is linear. If so, write it in standard form. Our first equation is y equals x squared minus 4. So no, this is not linear because it has a variable squared. It has an x squared in it. Our second equation is 6 plus xy equals x. And no, this is not linear either because notice right here we have an x times a y. And remember that you cannot have two variables multiplied together. Example number 3, y equals 1 over x plus 2. This is not linear either because notice x is in the denominator, and you cannot have a variable in the denominator of a fraction. Number 4, negative 2x minus 3 equals y. And yes, this is linear because notice it does not have any squared variables, no variables multiplied together, and no variable in the denominator. So what we need to do is write this in standard form. I'll just recopy it over here and recall that standard form is ax plus by equals c. X and y are on the left of the equal sign, and what you have over on the right is just the number c. So notice my y is on the right hand side. First thing I'd like to do is maybe move that to the other side. So I need to subtract y on both sides. So that's going to give me negative 2x minus y minus 3 equals 0. Now I need to move this 3 to the other side, so I'll add that to both sides. And that gives me negative 2x minus y equals 3. And it looks close to standard form, but remember that a cannot be a negative number. I can't have a negative 2 in front. So I'm going to multiply the whole equation by negative 1, and distribute negative 1 3 times, and that gives me 2x plus y equals negative 3. And that is in standard form. My a is 2, my b is 1, and my c is negative 3. Example number 5, 2/3 x minus 1/3 y equals 2. And this is in standard form. The fraction may throw you off, but notice this x is not in the denominator, nor is this y. I wrote them in line with the fraction bar, which means I can leave them right there. So this would be 2/3 times x. Or if I wanted, I could move that x into the numerator. The problem with this is, even though my x and y are on the left side of the equal sign, I have a 3 in the denominator. So to get rid of that, I'm going to multiply the whole equation by 3, or 3 over 1, and distribute that 3 times to my x term, to my y term, and then to my constant term over here. And that's going to give me 2x minus y equals 6. And that is in standard form. I can have a negative in front of my y. B can be negative or c can be negative, but a can't be, and it wasn't already. Recall from chapter 1 when we talked about x and y intercepts that an x-intercept is where the graph crosses the x-axis and an y-intercept is where the graph crosses the y-axis. Looking at the graph of this pink line right here, you'll notice that negative 5 is my x-intercept because that's where the line crosses the x-axis right here at negative 5. And you'll notice that 3 is my y-intercept because that's where the line crosses the y-axis right there where y is 3. You'll also notice that at the x-intercept, the y is always 0, and at the y-intercept, the x is always 0. So that's very useful when we're trying to graph a line, as we'll see in a little bit. Here are a couple examples of problems like you'll see in the text. It says find the x and y intercepts of the graph of each linear function and describe what the intercepts mean. So for our first one, we have a graph here that's entitled Increasing Temperature. Time is on my x-axis, temperature is on my y-axis. This point right here is going to be my y-intercept, and this point right here is going to be my x-intercept. So my y-intercept is -4. And what that means is that when time is 0, whenever they started collecting this data, their temperature was -4 degrees Fahrenheit. So when the time equals 0, the temperature is -4 degrees Fahrenheit. My x-intercept is 25, and that means that's 25 minutes. When time is 25 minutes into the experiment or whatever it is, the temperature is 0 degrees. So 25 minutes later, the temperature is equal to 0 degrees Fahrenheit. Okay, now we have values in a table, and this describes the position of a scuba diver. My independent variable is my time in seconds. My dependent variable is his depth in meters. So right here where x is 0, that's going to give me my y-intercept, which is a -24. And that means when they started taking the data, the diver was 24 feet below the surface of the water. Or, I'm sorry, 24 meters below the surface of the water. And my x-intercept is going to be the value of x when y is 0, and that's 12. So that means that 12 seconds later, the diver's depth is 0, or in other words, he's on the surface. Okay, let's take a look at an example where we can use the x and y intercept to help graph a line. So here we have the equation x minus 2y equals 4, and we need to graph it using x and y intercepts. So I'm going to start by graphing my x-intercept, and to find my x-intercept, I'm going to let y equal 0. Because remember, at every x-intercept, y equals 0. So I'm going to take that 0 for y and plug it into my equation. So x minus 2 times 0 equals 4. This is going to give me my x-intercept. So just continue solving this. So x minus 0 equals 4, or x equals 4. That's my x-intercept, and it gives me the point to graph 4, 0, because my x is 4 when my y is 0. Now to find my y-intercept, I'm going to let x equal 0 and plug 0 in for x into the original equation. So 0 minus 2y equals 4, or negative 2y equals 4. Solve that for y by dividing by -2, or y equals -2. That's my y-intercept, and that gives me the point 0, -2 to graph. So I will graph these 2 points. The point 4, 0 is right here. That's my x-intercept. The point 0, -2 is right here. That's my y-intercept. And to graph the line, I just connect those 2 points. There are 2 special lines that you need to memorize. And the first is x equals a number and y equals a number. When x equals a number and there's no y in the equation, it's a vertical line that goes through that number on the x-axis. An example of that is the pink line right here, which is x equals 4. It goes through 4 on the x-axis, and every point on that line has 4 as its x-coordinate. Y equals a number is a horizontal line that goes through that number on the y-axis. And that's my blue line here, which is y equals -5. This point right here is -5 on the y-axis. And in fact, every point on that line has -5 as its y value. And you just need to memorize those 2 lines. They'll keep coming up. And the last thing we're going to do here is graph a linear equation by making a table. And here we have the line y equals 2x plus 3. So I'm going to make a table and choose some x values. So I'm going to make an x column. I'm going to take what y equals and put that in the middle of my column. Y equals 2x plus 3. And then I'll make a column for my y values. So I'm going to pick 5 values of x. I'm going to use -2, -1, 0, 1, and 2. That's nice. They're easy. They're small numbers, and it gives me some negative, a 0, and some positive numbers. So since x is my independent variable and I could choose those, I'm going to plug those in for x. So I'll start by plugging in -2 in for x. And since y equals 2x plus 3, this is going to tell me what y is. So -2 times, or 2 times -2 is -4, plus 3 gives me a -1, and that gives me the ordered pair -2, -1. Now let's plug in -1 for x. So 2 times -1 plus 3. 2 times -1 is -2, plus 3 gives me a +1. So when x is -1, y is a +1. Plug in 0 for x. I like zeros. That's always easy. That's going to be 0 plus 3, which is 3. That gives me the ordered pair 0, 3. Notice that's going to be my y-intercept since my x is 0. Plug in 1 for x. 2 times 1 is 2 plus 3 is 5. Gives me the ordered pair 1, 5. And then plug in 2 for x. 2 times 2 is 4 plus 3 gives me 7. And that gives me the ordered pair 2, 7. Now let's graph these points on the coordinate plane. So -2, -1, -1, +1, 0, 3, 1, 5, and 2, 7. And they should create a line, so connect those with a line, and that's how you graph a linear equation by making a table. In this lesson, we talked about graphing linear equations. First of all, we figured out what made an equation linear, and that is it can't have anything squared, any variable raised to a power, two variables multiplied times each other, or a variable in the denominator. We talked about standard form, which was writing the equation of the line in ax plus by equals c form. We remembered what x and y intercepts were and showed how to graph using the x and y intercepts. We showed here how to graph by making a table, and we looked at two special lines that you'll need to memorize, that is when x equals a number and when y equals